Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 6th question from the King David's High School Preliminary Exam, which was written in the year of 2023. Please do expect a total number of 12 videos, since the question paper had 12 questions in total. That simply means each and every question will have its own video. Yes guys, it's an IEP question paper. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly your final examination. So please do share the video to your peers so that they may have the same edge as well. And please guys, do help us grow the channel by just subscribing. Okay, we are given an equation over there: y plus 2 minus 4 all over x plus 1 is equal to 0. They want us to sketch the graph on the axis below, and you must indicate all the intercepts with the axis as well as the asymptotes. Okay, the first thing I need to do guys is to make sure that I isolate y so that I can simply have the equation of my graph in standard form. This graph can be written as y is equal to positive 4 over x plus 1 minus 2. Are you together? So if ever guys my graph is like this, I now know that okay, my horizontal asymptote is basically y is equal to a negative 2, and my vertical asymptote x will be equal to negative 1. Are you together? For x I must change the sign. And then the next thing I need to do is to find both the x and y intercepts. Okay, for the x-intercept, I know that I just have to make y to be equal to 0 and solve x. Are you together? I'll simply say 0 on the left hand side. I have 4 all over x plus 1 minus 2. If I take the 2 to the other side, it will be positive, and then I'll have 4 over x plus 1. And then I'll just multiply both sides by x plus 1. I'll end up having 2x plus 1 is equal to 4. If I divide both sides by 2, then x plus 1 is just equal to 2, and then x is just equal to 1. So this is my x-intercept. And then for the y-intercept, guys, I just need to make x 0 and then solve for y. So y will simply be equal to 4 all over 0 plus 1 minus 2, and then the answer will just be y is equal to 2. So I know both the y-intercept and the x-intercept, and I also know both the horizontal and vertical asymptotes. The horizontal asymptote is over there. No, when y is equal to negative 2, negative 2 has to be below the x-axis. This is my horizontal asymptote, and that's my vertical asymptote over there. That's negative 1. Okay, let me write in black. That's negative 1 and negative 2. Okay, and then guys, if you can check over there guys, the value of a is positive. That simply means my graph is on the first and third quadrant of my asymptotes. Are you together? On the first and third quadrant of my asymptotes. One of the curves will simply be over there, and then the other one will simply be over there. Please make sure that guys your graph does not touch your asymptotes. Okay, I'll simply have a positive 2, there's my y-intercept, and a positive 1 is my x-intercept. This is how guys, this is how you draw your hyperbola. And then now I'm supposed to write down the equation of the axis of symmetry for the graph with a negative gradient. Okay, there are two axes of symmetry guys. The other one has a gradient of x of positive 1 rather, and the other one has a gradient of negative 1. These are the two axes of symmetry. It's either you have a positive gradient or negative gradient, right? This gradient over here is the one which is less than 0. So I know the gradient of my axis of symmetry, and then the point, I do know the point. I know that my axis of symmetry will just pass the point of intersection of my asymptotes. where x is -1 and y is just -2. I have -1 and -2. I do have a point and a gradient. I can simply find the equation of this straight line. I can say y minus y1 is equal to mx minus x1. So y minus y1 is basically -2, m is -1, and then x is just -1 as well. So I'll have y plus 2 is equal to negative x minus 1, and then I'll simply have y is equal to -x minus 3. So this is the axis of symmetry, guys. It will just pass like that over there. It will cut when y is equal to a -3. Okay, the graph below shows the function of g of x and h of x. The two functions intersect at point A. Okay, they want us to determine the value of b. I know that y is equal to b to the power of x. If I can substitute any point on f of x, guys, I can simply find the value of b. I do have a point on h of x rather, whereby y is 2 if and only if its corresponding x value is 1. So therefore b is equal to 2. B is equal to 2, né? Okay, and then now I'm supposed to write down the equation of the inverse function of h of x in terms of arc of h. If h of x, guys, is equal to 2 to the power x, for me to find the inverse, I just need to reflect the graph of h of x on the line y is equal to x. This simply means I just need to interchange both x and y. I'll simply have x on the left hand side and y there. But obviously, guys, whenever I write the equation of my graph, I must make sure that y is the subject of the formula. Basically, I must isolate y, I must solve for y. That means I must introduce the logs on both sides because I cannot make bases to be the same. I'll end up having the log of x is just equal to the log of 2 to the exponent y. Therefore y, let me not jump steps. This can be written as log of x is equal to y multiplied by the log of 2. If I divide both sides by the log of 2, I'll end up having y is equal to the log of x divided by the log of 2. But this thing, guys, can be written as the log of x base 2. So this is my inverse, né? So the inverse of h of x is basically the log of x base 2. Okay, and then now I'm supposed to determine the range of h of x if h of x is translated 5 units down. The range of h of x, guys, we can see that h of x normally h of x is just equal to 2x, né? So if ever I'm translating this graph 5 units down, that means the asymptote will simply be -5. Are you together? And over here, guys, the base with an unknown is multiplied by a +1, a positive number. That simply means that the graph is above the asymptote. Are you together? As we can see there, the graph is above the asymptote. So same thing applies over there. The range will simply say y is just greater than a -5. But if you want to express this in interval notation, you can say y is an element of -5 up to +infinity. Okay, number 4, we are told that using the graphs, determine the values of x for which this statement over there is greater than 0. Okay, I'll simply have -2x. I'll simply have -2x times x plus 6 multiplied by 2 to the x. If ever, guys, I have exponents separating. exponents subtracting one another, I can separate my exponents by using the law that simply says if a over b, if a to the power b is divided by a to the power c, this can be written as a to the power b minus c. If I want to separate these things, that means I just need to if I want to separate my exponents, I just need to apply this law. Né? So over there, I had 2 to the power x minus 1. That means I must divide there by 2. And then the answer on the other side will be greater than 0. I'll simply have negative 2 to the power x multiplied by x plus 6 divided by 2. This will just give me 3 multiplied by 2 to the x. And I still have greater than 0. I can take out a common factor, guys, which is just 2 to the power x. 2 to the power x. Are you together? Whenever I take out 2 to the power x, I will be left with negative x plus 3 is greater or equal to 0. Negative x plus 3, guys, né? I know that 2 to the power x, that's just h of x. And then negative x plus 3 is the other graph that you are given there, which is g of x. So they want us to find the values of h of x, rather the values of x whereby the product of both h and g is greater than 0. Basically, they want us to find the values of x whereby both of our graphs are above the x-axis or they are below the x-axis at the same time. Are you together? But the graph of h of x, guys, is never below the x-axis. So I'm just looking for the values of x whereby both of my graphs are above the x-axis at the same time. From this point over here, when x is less than 3, from 3 to the left, I can see that both of my graphs will be above the x-axis. So the answer over there, I'll simply say this statement is true. This statement is true whenever x is less than 3. This is the answer, guys. That's how, guys, we're supposed to tackle that question over there. So please do stay tuned, guys, and wait for more videos. Thank you.